of both paths of totality will actually cross.
You know where Blue Sky Winery is? That's in McCanda.
Yeah, right there in the middle of wine country, just a few miles south of Carbondale. And then, so the 2017 eclipse was only visible in the United States. It was visible from Oregon and then cut a path through the southeast across the U.S. So this one is actually going to be a little bit more, it's going to encompass all of North America, parts of Mexico, the United States, and Southeast Canada will be included in this eclipse this year. So I wanted to include this if you guys need a little memory boost. This was our Sky Tracker camera. Hopefully it'll load up for me here and play. This was a time lapse of what that looked like from downtown Paducah.
So that's 2017. You can see that's looking up Broadway. Broadway United Methodist Church is the church steeple that you see there. It's playing slow. Probably the internet connection is kind of slow here.
Yeah, bear with it.
You'll notice that it get darker here.
There we go.
So we did have some clouds around that day. Thankfully, at most vantage points, it wasn't obscuring anything.
Yeah. Actually, one of the interesting things with that time lapse, one thing, because the temperature actually started to cool down a little bit as the eclipse became near totality, we had less and less sunlight, the temperature dropped, and that actually sort of allowed the cloud cover to diminish a little bit as well. You know, on a summer day, you get these big, tall, puffy cumulus clouds that develop in the heat of the day. You get into the evening, those start to diminish as the temperatures cool. We actually saw a decrease in cloud cover sort of right up to the time of totality. And we also noticed, and I don't know, see if let's play one more time, there were some animal activity will change whenever the eclipse begins. I'm not sure. We'll try this one more time. If you look kind of over in this area at the end of the totality, you can see birds that are flying out. It affected their daily migration patterns, and so they were actually going to essentially go to roost for that, and so
I think they hang out down there at the sales, the Catholic Church down there.
So I'll play it through one more time here.
See the city lights come on, the street lights come on.
So anyway, that's what it looked like. This is the 2024 path. It'll come up across parts of Texas, clip Oklahoma, Arkansas, southeast Missouri, southern Illinois. You can see western Kentucky is just in the very little sliver of that. Indiana, Ohio, up into parts of Pennsylvania, and then New England, and then up into Canada. This is the path of totality. This is where you want to be in the colored section here. And we've got this kind of color-coded so that you can see the areas that are going to be in this the longest. And that's one of the differences from this year. 2017, it was what? About 2 minutes and 20 seconds?
Maybe 2 minutes, and it was a much shorter duration because we were sold the minimum then, right?
Right. So a shorter time frame in 2017. Again, this little yellow line here from Marion to Salem, Smithland, Paducah, that's where you get anywhere from maybe 30 seconds to close to 2 minutes of totality. But as you move farther to the northwest, it quickly increases here. Wickliffe and La Center, Metropolis, you've got over 2 minutes. You get up toward Vienna, if you go up I-24, all of a sudden you're over 3 minutes. And kind of in the sweet spot here from West Frankfort, Marion, Carbondale, Anna, Cape Girardeau, and back into southeast Missouri, this strip is over 4 minutes of totality. So we're really going to be able to soak it in and enjoy that eclipse. So that's kind of where the traffic is going to migrate. There's going to be a lot of visitors in places like Cape and Carbondale. I'm sure we'll have visitors here in Paducah, but compared to 2017, this is not the destination to be. It's farther north into southern Illinois and southeast Missouri this time. Going to talk through some of the
Sure.
times
Talk about
real
some of
quick.
the times and the start time and how long the eclipse will take place. Of course, through the duration, you can take your glasses off. When it's completely covered, you can take your glasses off.
Yes, only during totality.
Only during totality, but on either side of that, you have to have your glasses on, and it's really better to have them on the whole time. But if you take them off just to observe things around you, not necessarily the sun, observe animals, wildlife around you, feel how quiet it gets, that sort of thing. You'll notice on the opposing horizon, it'll look like sunrise. It's a little interesting if you noticed that the last time in 2017. As you go into southeast Missouri, really Cape Girardeau and Poplar Bluff are getting some prime time viewing for this eclipse. So they're going to be in totality for about 4 minutes in Poplar Bluff, just over that, about 4 minutes just over that in Cape Girardeau too, and that continues back down into Arkansas, portions of northern Arkansas. Anna, you can see over 4 minutes Carbondale as well, and that's where NASA is going to be stationed again. They were in Carbondale the last go around to do research, and because they're in that crossroads again, they're going to do their research in the same spot to see how it may be different and how things may be the same. So they also have a program at SIU. Dr. Bear up there leads a group of students that does astronomy work, so they're also getting to do some really neat research and getting to work with NASA, which is, you know, once in a lifetime opportunity for some. And so those are some of the places that are going to be the most duration. A lot of this starts right around 2 o'clock for most places in the local 6 area, especially western Kentucky. You can see Paducah starts right at 2 o'clock. So leading up to that, you're going to be wearing your glasses. 2 o'clock is the start of totality, and that's only going to last for 1 minute and 30 seconds. So if you're going to be at the riverfront, that's 1 minute 30. I would say if you're back closer to the airport or Bardwell, you're getting closer to that 2 minute mark. So the further south you go and to the east, so if you're in Reedland, is that on there?
No, don't have
Smithland is though. Smithland's just shy of 30 seconds, so Reedland's probably only about 45, 30 seconds.
Yeah.
That gives you an idea. If you just want to drive to Paducah even, just to get a little longer experience, that's worth the drive, certainly. Probably not worth the drive at this point to go to some of those 4 minute places, only because hotels are gone. Everything is booked in totality in that prime spot with the 4 minutes. Even media coming in from all across the country, everything is booked in those areas. But it's worth it if you have the day to just drive around and traffic doesn't bother you. That would be a good thing to do too, is to go to one of those places.
So, okay, what is a solar eclipse? What is a total solar eclipse? So this is where the moon aligns exactly between the sun and the earth and casts a shadow. It's really cool. This is a really awesome kind of a cosmic coincidence. So the sun is huge. It's 400 times wider than the moon, but it's also about 400 times farther away. So it makes them appear, from our vantage point, the same size, which allows us to be able to have an eclipse like what we're going to be able to witness. So there's 2 types of solar eclipses. There's an annular and a total. That has to do with the distance of the sun away from the earth. So the orbit of the moon. The orbit of the moon around the earth is not exactly, it's not perfect. It's actually an orbit, an oval. And because of that oval, there are times that the moon is farther away from the earth, and there's times it's closer to the earth. When the moon is actually farther away, is when you get what we call the annular eclipse. This is what we had in parts of the country in October of 2023 last year. For us, it was just a partial eclipse. But with an annular eclipse, because the moon is farther away, you get what we call the ring of fire. So that's where the moon does not completely cover the face of the sun. It leaves the outer edge of the sun still visible. We're lucky enough that we're catching the moon whenever it's closer in orbit, and so it will cast that complete shadow onto the earth and completely cover the face of the sun. So you think about, so we have a new moon every month. A new moon is when the eclipse happens. That's when the moon is in between the sun and the earth. Well, that happens once a month. So why don't we have an eclipse every month?
Because it's so short.
You want to talk about that one? No? Okay, so it has to do with the plane of orbit. So we've got the Earth, of course, it's tilted 23.5 degrees on its axis. So it's tilted here. And then the moon's orbit around the Earth is also on a tilt. If it was on the same orbital plane as the sun and the Earth, we would have a solar eclipse every month. But it's not. It's tilted at about 5 degrees. And so because of that, as it kind of tilts here, the shadow is usually either above or below the Earth, not right in line with it. And so, on average, it's about once every 18 months that we get the moon on the same orbital plane as the Earth and the Sun. So roughly once every year and a half, there's a total solar eclipse somewhere on the Earth. That's not exactly the case. There's variations of that, but on average, about once every 18 months. We'll talk a little bit about why this is such a huge deal.
Are you doing the phenomenon here?
Not quite yet.
Okay.
Yeah.
So it's special because it only is a 115-mile wide path that moves across the country. And we're lucky that the U.S. is in the path because a lot of times it's hitting over ocean or it's over the Arctic or places that don't include land because most of the Earth is water. So it's only 115 miles wide, and so a lot of people flock to that very narrow path just to be able to say they were in that path and experience all that comes along with that. And it's visible from any one spot on Earth, an average every 375 to 450 years. So the fact that that's how rare to be in it, kind of back to back, so close together. I think the next one, I see 2043, is that?
2044 and 2045. Yeah, I've got those.
Okay.
We'll talk about those here in a minute.
This one, like Trent said already, this one's going to last a little bit longer, especially in the middle of the path. Instead of it being about 2 minutes at totality, it's going to be 4 minutes in some of those locations that we talked about, like Cape Girardeau and Carbondale and Poplar Bluff. And we talked about, too, that this one is longer because it's the solar maximum. Instead of the last one in 2017, that was the solar minimum, and that's why there wasn't as long a period of time for totality.
Well, and with that, where there's more or less solar activity, in 2017 we're at a minimum. So yeah, you were able to see the corona, you were able to see some things, but there wasn't a lot going on. This year, there may be a lot more frequent solar prominences, little jets of gas that are shooting out from the sun. The sun's atmosphere may be overall more visible and more active. So if we're lucky enough to be able to actually see it, the sunshine that day, there may be a